Let's look at water extreme. The water extremes, we're going to talk about three different concepts: flooding, drought, and leaching. Not necessarily in that order. Drought is basically a prolonged water stress that occurs when you don't have enough water coming in. You saw the map in the United States. There are areas where we get less than 5 inches of rain on an annual basis. These would be considered to be desert type areas, which means we're going to get some sort of prolonged water stress out of these. It could be that you may not get water over a very long period. Driest place on planet Earth is a place in northern Chile, which is called the Atacama Desert. They have had no measurable rainfall over the last 350 years. That's really prolonged water stress. When we look at it, sometimes we talk about plants and the way they survive in these, and we have drought resistance, which means the plant has the ability to survive in bad times. This could be something like a desert plant. This is a Joshua tree. This is in Nevada. You can see this does not look real nice and green. You can see the material under this has actually dried up. It has already produced its seed. Seed is waiting for time that it can find water to be able to grow. The Joshua plant, it's doing fine even in the desert like that. This is the resurrection fern in Florida. These grow on live oak trees. When we get a drought of more than a week or two, these will start to dry down. They will look like they're dead. You throw some water on it, all of a sudden it comes back to life. That's why we call it a resurrection fern. We have escape, which often goes in with certain desert type plants. The low vegetation down there around the Joshua tree would grow for a very short period of time when there was water. When there's no water, it stays like that, just waiting for the water. We can have dormancy, which would be something like what you're getting with the resurrection fern. In dormancy, what happens is you actually have a reduced plant life because the plant can't grow as quickly because it doesn't have the water there. This is a picture of the Dust Bowl. In the Dust Bowl, the center part of the United States, they had plowed everything up. They didn't get a lot of rain 1 or 2 years. What happened was everything dried out and didn't have vegetation on the top. Windstorms would come through, it would pick up dust, and it would blow the dust away. A lot of this occurred in Texas and Oklahoma. The Dust Bowl affected everything all the way up to Boston because clouds of this dust would be picked up into the stratosphere and then would fall down in Boston. You could see something like this. This is prolonged extreme drought. We have wilt that occurs from drought. Wilt is basically a loss of turgor due to the plant not being able to have enough moisture. There's a couple of different kinds of wilt. We've got what we call a wet wilt, where the soil moisture is not limiting, but rather there's a poorly developed root system. A poorly developed root system is not picking water up. If you overwater, this tends to happen. When you overwater, you saturate the upper part of the soil. What will happen is the roots will stay very shallow. As soon as you miss a day, you're going to get a wet wilt because the moisture has been removed from the upper part of the soil. There's no more moisture there, but the soil itself may have moisture down deeper. The plant can't get to it. We also have a permanent wilt. In a permanent wilt, you get death due to denaturation of proteins. When permanent wilt occurs, there's not much that's going back. You can't revive a plant that has permanently wilted. This is a picture of a squash plant. You can see how the leaves have lost turgor, how they are wilted. It's at a certain point, some of these leaves have permanently wilted. Some of the plant has temporarily wilted. This really turns into a problem because you've got to be able to figure out how to get the plant back up. And one of the only ways is you've got to be able to irrigate this. One of the great problems farmers have is trying to figure out when to irrigate because irrigation costs a lot of money. Once you start, sometimes you have to maintain it. You can have excess water. Excess water can come from poor internal drainage, which means the soil doesn't drain itself very well. Things that tend to have high clay layers have problems like this. Where I grew up, we had what we called a hard pan, which was a clay layer at about 24 inches down. Anytime you planted larger things like trees, you had to auger through that layer, which was about 3 to 5 inches deep. When you did that, it poked a hole that allowed everything to go down. With that layer in there, it would not be able to go down. This is an old school picture, dates back into the 40s. In this particular case, what it's showing you is water being applied to a soil. You can see that you've got an upper layer that is very homogeneous. Then you've got a layer of sand. Below that, you've got a layer of soil again. again. What happens is the water penetrates down, but it will not move through that sand layer until all of the pore spaces above it are saturated, which means you can see it at 0.3 hours, it just about reached the sand. At an hour and a half, it still hasn't gone through the sand, but it's spreading out on top. This is poor internal drainage. Same sort of thing would happen if you had a layer of clay down below it. We can have inadequate surface drainage. If something is too flat, it doesn't drain water off, and it doesn't shed excess water. We can have excess rain. In Tallahassee, we have had storms where we have had up to 24 inches of rain in a 48-hour period. 24 inches of rain in a 48-hour period is excessive. There's no way to be able to get rid of that rain. This all adds to excess water. Sometimes you leave your irrigation on too long. One of the big problems you have with houseplants is people tend to overwater them. You could have what we call a high water table. We're talking Florida. How far do you have to dig down to reach the water table? In certain areas at certain times of the year, it's no more than a couple of feet. You go down to South Florida, it used to be all swampland, which meant the water table was right up at the soil line. What they've done is they would excavate out, create canals. They would take that material they excavated out and spread it. You'd get higher land, you'd get a lower water table because you took out the area. You'd get a nice area that's got canals. All of that is high water table. This is a picture of a housing development in South Florida. The water table level here is the level of the pond. This pond is not fed by a stream coming into it, but rather it is fed by rainwater. You can see the highest area of the high water table, which is where the pond was. There is no vegetation growing. This is after a drought time where the water table has actually dropped down considerably. As rains come back, this will fill back in. At one point, the whole area in here was underwater. What they did was when they dug out the pond, they took the material that they dug out, spread it up on the top. That's where they built the houses at. High water table becomes very interesting. You can have flooding. Flooding is where you just have too much water and it doesn't go anywhere. What all of this does is it fills the large pore spaces in the soil. When it does that, you lose aeration to the plant roots. That's going to cause damage to the plant roots because the plant roots can't do their respiration because they don't have enough oxygen. This is a picture of flooding. You've all seen flooding before. All of these plants, these are not plants that are developed for this particular type of flooding. You've got this really nasty flooding in there. Leaching is another problem we get from excess moisture. Leaching is basically the removal of a soluble material through water drainage. As water comes down and it gets into the soil, it solubilizes nutrients because the pH of the water is going to have hydrogen ions which are going to dislodge nutrients. As they dislodge the nutrients stay in the water solution. As that water solution drains internally within the soil, it's going to remove them out of the area where the plant can get in contact with it. We call that particular problem leaching. Leaching is cation exchange capacity dependent. The higher the cation exchange capacity, the less tendency you're going to have to leach. That's where you get a more fertile soil. The lower your cation exchange capacity, the more sand you've got, the quicker you can leach things out. The quicker it becomes a problem. Low cation exchange soil leaches rapidly. This is what we get in Florida. If you don't have the organic matter in there on a sandy soil, the sandy soil has no ability to hold nutrients. It doesn't have any ability to hold water. It doesn't have any ability to really farm well. In desert areas where they've got no real soil structure because it's all sand, you've got problems with nutrition. Another problem with leaching is leaching causes groundwater contamination because the leachate is going to go down into the groundwater. It's going to stay there. And if you try and use the groundwater for something else, you're going to have problems with accumulation of materials in the groundwater. If you look at what happened in Detroit with the water system, what they were talking about was leaching. If they had added a certain chemical, it would have suppressed the solubility of lead. Since you didn't, pulled the lead out of the pipes and created a horrible problem for everybody.